Let's start here in SOLIDWORKS 2018. Since I have a certified professional graphics card, I'm going to turn on Real View Graphics, which in CAD design mode gives me enhanced shadows, reflections, and texture maps, making for a much more realistic view while I'm designing the product. However, the level of photorealism can go up dramatically, and that's what we're going to do with ProRender. If you'll notice, the ProRender add-in is seamlessly interfaced into the SOLIDWORKS UI, so it's very easy to learn and to use. I'm going to verify here that my rendering job is going to take place on my two Radeon Pro WX9100 cards, so I should get great rendering performance. I'll go ahead and check my settings and open up the rendering window, and the ray tracing is about to begin right before our eyes. Now, while that's loading, I can take a look at some of the other things that I can do with ProRender. For example, I have the ability to apply decals to the rendering. I can change the environment to use physically based lighting or image-based lighting, location-based lighting. I can apply post-processing effects. Another nice thing, especially with the sort of power that I have here, is the ability to change the camera angle in practically real time. And we'll see that ProRender is generating photorealistic reflections and shadows and a beautiful image resolving right before our eyes using the power of these two GPUs in this system. Now, another feature that we added to ProRender, specifically for VR in mind, is the ability to manage the number of polygons that get generated on a part-by-part or assembly-by-assembly basis. So the general rule of thumb is if I have a flat surface, I don't want to generate a lot of polygons. That's going to bog me down in VR. So I'll set the mesh quality for this measuring backplane here to low. And when I check the blade guard, I will set that mesh to high so I get nice smooth rounded curves, and that is going to allow me to intelligently manage the total number of polygons that I transfer into the Unreal Engine. So when I'm satisfied with the output, I have a single button click to export the ProRender scene, and I am now ready to move over to the Unreal Engine, where I'll import this ProRender scene with all of its geometry, lighting, and materials information, and let's see what we can do with it in VR. So before I get into the Epic Games Launcher to launch the Unreal Engine editor, I'm going to make one quick change to my graphics environment. This is a unique capability offered by the Radeon Pro WX series graphics cards, where I can switch into the driver options. You saw earlier when I was showing SOLIDWORKS and the Real View Graphics, where I had enhanced realism in my design mode in SOLIDWORKS through the support of our professional drivers. However, I also have the ability with the Radeon Pro graphics cards and software to change over to the gaming driver, which will give me higher performance in VR and in Unreal. So I'm going to go ahead and make this change before we launch into the Unreal Editor. Here we are using the Epic Games Launcher to launch the Unreal Engine. We're going to go ahead and create a new project, and since our target is virtual reality visualization of the SOLIDWORKS model, we'll use the VR template provided by Unreal. Let's give this a name for our project. And note that we are using Unreal Engine 4.17. That is the version that the Radeon ProRender Games Engine importer currently supports. We are doing our best to stay current with Epic's engine release cycle, and we'd certainly appreciate feedback from you in the user community about what support you need, which versions you need. Here in the Unreal Editor, I go ahead and navigate to the map that has the motion controller support, and that basically sets the stage for my placement of the ProRender objects. I can import the ProRender object either from this button on the toolbar or from the standard import button here. And there is my ProRender scene file. And I have multiple choices of how to import the asset, how to import the model. If I choose the various assemblies, it will honor the CAD hierarchy the same way that we saw the hierarchy of assemblies in the ProRender window when we were doing selective decimation of different parts and assemblies to change the mesh quality. For the sake of simplicity, we'll go ahead and just combine everything into one single asset. And I'm not going to import the lighting from the ProRender scene. I'm going to add lighting in Unreal, and I will choose Physics and choose Import. Now, I will note here that the Unreal Engine is a very powerful and sophisticated development environment, and it will take whatever resources you give it in terms of CPU, GPU, storage, memory. So while CAD users are accustomed to having fairly high-powered systems and professional graphics, that may not necessarily be enough to run Unreal Engine at a satisfactory performance rate, and also VR. There are certain minimum specifications and requirements for VR. So keep that in mind as you select your system or determine whether you can use your existing system. And the object will import here. There is a bit of time required as each of the appearances, each of the SOLIDWORKS appearances that were converted into ProRender materials are now being converted into Unreal shaders. And so the more shaders you have in the asset that you're importing, the longer this process will take. But even the largest assets that we've seen, it's simply a matter of maybe tens of seconds or single-digit minutes. And again, that also depends on the speed of your machine. Okay, so now I am here. There is my object, and I'm in the blueprint editor for Unreal. This is where we assign properties to the object, such as physics. So these are all the materials that were converted from ProRender physically correct materials into Unreal shaders. And I will turn on physics, and I'll show you why I do that in just a second. Now I will compile the blueprint, close the blueprint editor, and now the object appears in my scene. Now it's down below the floor because it was centered at 0, 0, 0, and that puts it below the scene. So I'm just going to go ahead and raise it up a little higher. The other thing that I need to do in order to light this scene properly is to add what's called a reflection map. So when you have materials on your property that have reflective surfaces, like the stainless steel and the chrome on that object, a reflection map is required in the scene. So you can see as I move the reflection map around, it's going to change the lighting a little bit. So it doesn't matter where I put it, I just need to have a reflection capture sphere in the scene. And now I should be ready to go. So I am going to play this preview in VR. There, and we just saw the gravity took effect, and I'm going to put on my VR headset. And using the tools available in the template, I can interact with the object. I'm going to grab a block here. You can see the block interacts with the object. and I can inspect the object, look around it, even look through it if I choose. And there we go. I've gone from SOLIDWORKS into Unreal using the ProRender game engine importer, and I am now able to visualize my asset in virtual reality with Unreal Engine's tools. I'd like to show one more thing. It's a little deeper than I wanted to get in this particular webinar, but I'd be happy to put up a YouTube video that goes through it step by step. It takes about 35 more seconds to program the blueprint to enable picking up the object. So I went ahead and turned that on offline here, but you can see now that I can get up to the object, grab it, drop it, turn it around and inspect it, hold it up to the light and see different light interactions with the different materials. And I can even throw it. So it's just a bit more work inside the blueprint editor to enable picking up and dropping an object. But like I said, please provide feedback about your interest in this capability, and I can post a more in-depth tutorial at higher resolution so you can see exactly what's going on to enable this capability.